Before we move on to how to actually do our hypothesis test and then doing some to practice, we need to talk about where hypothesis tests can go wrong. So to begin with, let's actually focus on one type of hypothesis test. So let's say we have a standard normal distribution, and we're doing a right-tailed test based on our level of significance alpha. So this area to the right is going to be based on the size of alpha. This is what's called the rejection region. So the rejection region is where we would reject our null hypothesis if, when we find our critical value, or our test statistic rather, whether it falls into here. This would mean that we reject the null hypothesis. If it were to fall into this region, this would be our fail to reject region. So there's basically four different possibilities. You can have a null hypothesis that is true, in which case you can fail to reject it, or you can reject it. Or you could have a null hypothesis which is false, where you could fail to reject it or reject it. Now, this null hypothesis is true or it's false, but we don't know that, because if we did, we wouldn't be doing a hypothesis test. And this is where I kind of mentioned previously that there's always this possibility for error, because one, we could have a null hypothesis that's not true and we don't have enough evidence to reject it, or we could have a null hypothesis that is true and we end up getting enough evidence to reject it. Or it also could be that because this rejection region is based on my alpha level, I could change alpha and end up with a different rejection region. And if my value falls right there, one instance I would reject the null hypothesis, another one I would fail to reject it, all based on the same data. So we have to take into account these types of error, right? Because we're using sample data, so we have to consider that this error is definitely possible. So when making a decision, we're going to encounter the following four scenarios. So I'm going to create this box here, and at the top, I'm going to have whether our null hypothesis is true or false. So in this case, we have a null hypothesis that is true, and in this case, we have a null hypothesis which is false. And then on the side, we're going to put what our conclusion was. So either reject the null hypothesis, or we fail to reject the null hypothesis. Now, if we have a true null hypothesis, we would want the data to say that we do not reject the null hypothesis. So if we fail to reject it, this would be the correct decision. Similarly, if we had a false null hypothesis, we want the data to show that we can reject the null hypothesis. So if we were to reject it, this would be correct. Now let's talk about where we actually can have a problem. What if you have a true null hypothesis, a null hypothesis that is true? For in our prior example, we had that the SAT scores mean mu equaled 500. And let's say that we get some data and we show that it's not equal to 500. Maybe it's more than that. But actually it is equal to 500. So we have the wrong conclusion. This would be a type 1 error. So type 1 is when you have a true null hypothesis that is erroneously rejected. If we have a false null hypothesis and we fail to reject it, this is called a type 2 error. Now, what does this actually mean? Well, it just tells us what kind of error are we performing, right? If we were to reject a true null hypothesis, we've committed a type 1 error. If we fail to reject a false null hypothesis, we have a type 2 error. So let's look at what this means in sort of some real-world examples. Let's say that you were looking at the American court system where we have the assumption innocent until proven guilty. So your null hypothesis is that the person is innocent. Now, is the person actually innocent or not? That would be your true or false actual null hypothesis. If they committed a crime, this would be false. This null hypothesis is false. They did commit a crime. They're not innocent. Or this null hypothesis is true. They are in fact innocent. But based on that, we go through the whole court proceedings and we can have two possibilities. Either they're found that there's enough evidence to say that they're not innocent, therefore rejecting the null hypothesis, or we didn't find enough evidence to reject the null hypothesis, therefore that we claim that they are in fact innocent. Now, we all know from actual court of law that there are errors that are done, right? We have innocent people who are found guilty, and sometimes years later they're exonerated, or we have guilty people who did commit a crime who were found not guilty because there was not enough evidence to say that they were not innocent. And this is where you have to be very careful with these types of error, because again, this is based on your threshold for what will cause you to reject or fail to reject the null hypothesis. And this a lot of times is going to be based on how conservative or stringent do you want to be about rejecting or failing to reject, right? So in this case, it would be, is it better that no guilty person gets off? So therefore, you might have a much lower threshold, which means you have a bigger rejection region for finding someone not innocent, in this case, guilty. Or is it more important that no innocent person should ever be found guilty and possibly go to prison? In which case you might have a much smaller alpha so that you would have less people who are innocent being found guilty. But because of that, more people who were actually guilty of a crime would also be found not guilty, or there's not enough evidence to prove this. Some other examples might be things like cancer screening or pregnancy test, right? So when you were doing a pregnancy test, you were either pregnant or you were not pregnant. The test can give you one of two answers, pregnant or not pregnant. Well, if you are pregnant and you're found not pregnant, then this would be a type of error. If you are pregnant and it says you are not pregnant, this would also be a type of error. And whether it's type 1 or 2, it depends on what your initial claim is. Is your initial claim probably not pregnant, because that is the default state? So in this case, we might say, okay, well, the default or the null hypothesis is not pregnant. So if you are in fact not pregnant and we reject that, that means that the test would say you are pregnant, meaning you have a type 1 error. If you are not pregnant, which means your null hypothesis, if you are pregnant, which means that this null hypothesis is in fact incorrect, but the evidence says that no, we failed to reject it, we say you're not pregnant, this would be a type 2 error. Now, the reason that this might be important is because this could actually affect what you do in the future, right? If you have a type 1 error, which means that you are in fact not pregnant and it rejects it, then you would possibly start acting as if you are pregnant. Now, mind you, this is why a lot of times in medicine, you'll get second tests, second opinions, things like that. So you might stop, doing things like drinking alcohol, you start taking vitamins to make sure you're, eating healthy, all that kind of stuff, and you're not really doing it for any reason. Or let's say that this null hypothesis, that you're not pregnant, is false, meaning you are pregnant, and you get a type 2 error, meaning we failed to reject that you were not pregnant. So the test says you're not pregnant, you are pregnant. So now, because you believe you're not pregnant, you go out doing your normal lifestyle and possibly put your child at risk. So generally, we will actually err towards one side or the other of the decision based on which one would cause the most harm. Somebody thinking that they're pregnant when they're not is less likely to cause bodily harm than someone who is pregnant but thinks that they're not. So in this case, we would probably have an alpha level that's selected so that we're more likely to get type 1 error than type 2. And this is where the key aspect of this comes, because as you change your alpha, as type 1 error increases, type 2 error decreases. As type 2 error increases, type 1 error increases. So this means that as one goes up, the other one goes down, meaning you can't ever control both of them. So now let's actually break down what this looks like whenever we're actually doing these types of error. So we're going to begin by drawing our normal distribution, which, by the way, this still works the same way if you have a student t distribution. It's just that your probabilities would be different because it looks a little bit different. But we're going to say, because we're assuming that the null hypothesis is true, we're going to have a normal distribution that's centered on mu. We're going to have some alpha, which will determine our rejection region. So we have our rejection region. So now we have, again, 4 possibilities. If we have a null hypothesis that is true, and it lands in this region, which is the fail to reject region, this would be correct. If we have a true null hypothesis and it lands in this region, this would be incorrect. And in fact, this would be a type 1 error, right? Because we have taken a true null hypothesis, but we've said that it's not true. But we're wrong because it is in fact true. But again, we don't know that. Or we could have a null hypothesis that is false. And if it lands out here and we reject it, so we did the proper thing. We have a false null hypothesis, and our hypothesis did reject it. This is correct. Whereas if we have a null hypothesis which is false that lands on this side, this would be a type 2 error. And this is what it means. It's basically, where does it fall in our rejection region, and is it true or false? And this is why we actually have two different types of error. And where a lot of confusion comes from, though, is then what is the probability of each of these occurring? So if our null hypothesis is true, that is, we have a null hypothesis statement that is in fact correct. If we get the wrong answer, then the probability of getting this type 1 error is going to be called alpha. So the probability of type 1 error, type 1 is alpha. And if we have a null hypothesis which is false, and we were to erroneously put it into this failed to reject region, a lot of people might think, okay, well, this alpha, so this is 1 minus alpha. It is, but not so fast. So the probability of getting a type 2 error is going to be equal to beta. And this is because we have to consider the other cases, right? So if I have a null hypothesis that is true, if I say that it is true, this is the opposite, the complement of this alpha. It's the rest of the region. So this is actually going to be equal to 1 minus alpha. If I get it incorrect, this is a type 1 error, and the probability of that occurring is alpha. If my null hypothesis is false, and I reject it, or fail to reject it, well, we just said that if I have a false null hypothesis, which I want to reject, if I fail to reject it, we said that the probability of this is equal to beta. So the probability that it correctly reject my null hypothesis when it's false is going to be 1 minus beta. Now, when we're doing a hypothesis test, our applications of doing a hypothesis test, we only really control our alpha level, which means we are controlling the type 1 error, right? Because by where we put our alpha, we actually are controlling what is our probability of erroneously rejecting a true null hypothesis. So in this case, this is why we tend to veer away from words like prove or show or say that it's true, and we just say that do we have enough evidence to reject or fail to reject at some level of significance. It's difficult to control a type 2 error, so this is again why we avoid that language. So to kind of conclude this, we have our type 1 error, which is when we have a true null hypothesis that we reject. We have a type 2 error, which is when we have a false null hypothesis that we fail to reject. The power of a test is our probability of rejecting a false null hypothesis. In fact, this is when you're doing power analysis on a test. What you're doing is you're looking at how well will it be able to reject a false null hypothesis. So your power is going to be based on 1 minus beta. So 1 minus beta will be the power of a test. It is how well will you be able to reject a false null hypothesis. Alpha is our probability of a type 1 error. This is where we have a true null hypothesis and we reject it. Beta is the probability of a type 2 error, which is when we have a false null hypothesis and we fail to reject it. And then again, this 1 minus beta is the probability of the power of our test. It is the probability of rejecting a false null hypothesis. And this is mostly what you need for error whenever you're looking at a hypothesis test. Now, I do want to note there is actually one other type of error called type 3 error, which is where you actually make the correct conclusion, but you do it for the wrong reason. So this might be something like where you have a false null hypothesis, you do reject it, but you actually rejected it for the wrong reason, right? You got the right answer, but it was mostly by accident. Thank you for watching. To continue learning, click the linked video here for the next lesson. If there's a topic you'd like me to cover, let me know in the comments. Don't forget to subscribe, and I'll see you in the next video.